So this is our game plan tonight. So what is the cloud? We're going to talk about that, obviously. Why would you migrate to the cloud? Adopt a cloud native mindset. So that's basically, adopting the cloud, but in a sensible way, the best way that you can, in my opinion, and the most exciting way as well. It's all a bit dull otherwise. We're going to look at security, which is actually in the wrong order. That should be data first, and then we're going to look at security data as well. So that's the agenda. So we'll move on. This is me. I'm not going to go into too much detail on this, but basically I've been working in IT all my life virtually, and various different organizations, government, public sector, financial services. I started working in private cloud back in 2010 with VMware, and I've been 8 years working exclusively in public cloud like AWS, Azure, GCP. And end of last year, I founded Secure Bubble, which is basically my own business. I'm a freelancer, which is wonderful because nobody tells me what to do. I do whatever I like. It's great. So it gives me time to do things like this as well, which is brilliant. So that's me. So we'll start off. What is the cloud? So there's 4 main principles basically for cloud, what we would call cloud. Number 1 is it's got to be available. And when I say available, I mean you can access it without sort of phoning someone up or putting a phone request in or putting an email or a call request or whatever it be. It's basically you go on there, you open a website and you've got access to it and you can do what you like. So that's one of the main aspects to call something cloud. The second is it's elastic, it's scalable. And that means different things based on the cloud provider. The hyperscale providers obviously can scale to huge numbers of applications and users that you can use. Except Microsoft in some of their regions, yeah. But in theory, it should be able to. But yeah, you can scale up and down as well, basically. So you can scale up when you need it, and you can scale down when you don't need it. Multi-tenant, so that's a key aspect of cloud, which basically means it's a shared platform. Now, that can mean different things in different aspects, but the main aspect of sharing is the fact that you can lower the cost. So you're not using kind of traditional infrastructure where you have a server for each different application and things like that. You've got the idea of sharing all of the aspects of infrastructure and making cost savings as a result of that. And utility pricing is one of the main benefits of it. So it's pay as you go, basically. So if you spin up a server, you pay for it. If you shut it down, you don't pay for it. Simple as that. So that's the 4 key aspects that make something cloud. And we've got 3 deployment models. We've got public, private, and hybrid. And the easiest way to kind of think of them is a bit like bus, car, and a mixture of both. So with the public cloud, which is the big providers like AWS and Azure, it's a bit like getting on the bus. You get to the bus stop and you get on and you pay a little bit of money and it takes you where you want to go and you get off and that's it. And you use it as and when you need it. And it's pay as you go, and it's a shared platform. Lots of people can get on the bus. It's open to everyone basically. Whereas the private cloud is more of a kind of a car basically. So it's where an organization might set up their own cloud in their own company. It's got the cloud principles that we talked about before in terms of being scalable and elastic and all of those things, but it's dedicated to them. So in order to do that, they've got a huge upfront cost because they've got to buy all of the servers and the networking infrastructure and the storage infrastructure to build that cloud. So it's a huge upfront cost, a bit like a car, but it's their platform. They choose who goes on it. It's like a car. They can choose who can use it and who can't use it. And then hybrid cloud, which is obviously what a lot of most companies do, is using both. So some things make sense on private cloud, some things make sense on public cloud. So they've got both available to them to do that. So this is public cloud, what we've been through before. There's a few names up there, AWS. So there's hundreds of different cloud providers, if not thousands. There's the big ones that we've mentioned, Amazon's and Microsoft's and Google's, but there's also the little providers that are really good for some aspects, like DigitalOcean, Vultr, Linode, and I put RedCentric up there, which is a UK sovereign provider, basically, which might be important for some people if you've got to make sure that your data never leaves anywhere other than the country you host it in. For this example, we've got the UK. So they're a UK provider. All of their data is in the UK. They don't have any kind of presence in another country, and it's owned by a UK company. So the laws of the UK apply, and there's no question of any other kind of countries being able to do anything with that. So some government organizations, obviously that's incredibly important. Here's private cloud. So on the left-hand side here, we've got the physical stuff, servers, network, storage, and there's some big names that you get from that. And on the right-hand side, we've got how we turn it into a cloud, basically by calling what we call virtualization. So we're turning all of these servers into an area where we can just deploy as many virtual servers as we can, essentially. We've got a network layer, so we've got divided, instead of having switches, physical switches you're plugging into, you're not worried about that. You're worried about virtual networks and VLANs and things like that. So it's all virtualized, and the storage layer is the same. And these are kind of the providers, the main providers on the right there that do that kind of virtualization software. I mean, there's loads more, but I've just put some recognizable names up there. So VMware, Azure Stack, AWS have got their version, and these all run in your own data center, basically, but they give you cloud-like performance. And then finally, there's the hybrid cloud. As we've discussed, it's a bit of both. So you've got your private cloud here, which is running in your data center with your virtual machines that no one else can access. And then you've got a public cloud platform over there running an application. That might be an application perhaps that isn't used much, but sometimes when it is used, it's huge demand. And so therefore they put it in the public cloud because it can scale up massively when it needs to, and they can scale it down when they're not using it. And therefore it's a lot cheaper than running it in their own private cloud.
Can I take an issue with that slide?
Yeah, sure.
It's on premises.
You can take an issue with that if you like. I'll correct it later for you.
Look, John, there's two people in this room now that might have made that mistake. Because I'm the other one. So we can hang up on you.
Yeah, but you're still wrong.
Right. Two wrongs. So the next model we're going to look at is service models. So these are, you may have seen these before, 3 different main service models. There's lots of other kind of offshoots to this. We've got infrastructure as a service, which is what we've kind of looked at a bit before in kind of private cloud, virtual servers, virtual networks, that sort of stuff. So it's kind of virtualization of your traditional hardware infrastructure. Platform as a service is where things get a bit more interesting. We're not looking at kind of virtual servers with with operating systems. We're just looking at more of an aspect of something that you can run on something. So an example might be a managed database, which we'll come onto later. With that, you spin up a database and you can just connect straight to the database. You haven't got to install the server, install the database software. You haven't got to maintain the operating system or antivirus and things like that. And then you've got software as a service, which you've all been using for years and years and years. Anyone that used Hotmail was using software as a service. It's an email provider. You just log in, you log on, and you use it. You don't have to do anything about setting up any of the infrastructure and things like that. So Microsoft Office 365, Google Analytics, Google Drive, all of those things, they're all examples of software as a service. And that's a little bit more there, just some examples of those various platforms and things that we've been talking about. This is like an analogy that sometimes helps people. So if we think of when you're cooking a pizza, so you've got an on-premise solution where, let's say you want to cook a pizza, but you've literally got nothing. So if you want to do it all yourself, you've got to source yourself a kitchen, an oven, and you've got to get some pizza dough. So that's kind of like the on-premise aspects of getting a data center, getting the hardware, getting the hypervisor. You've got to do all of that first. Now, if we go to infrastructure as a service, we're not doing that. We don't worry about it. Someone else is providing the kitchen and the oven. We just turn up with our tomato sauce base that we're going to make and our toppings and all of that, basically. And that's kind of infrastructure as a service. So we're coming down a layer. We're not having to worry about those aspects. And then if we're looking platform as a service, we've got somewhere and they've given us a pizza dough base to bake it on. They've put a lovely base on for us of tomato sauce, so it's all done for us. We've just got our toppings that we're putting on, be that pepperoni or not pineapple, obviously, anything that you want to put on your pizza. And then finally, software as a service. You've turned up and someone's just given you a pizza and you just basically go, great, that's lovely, and you cook it and then you eat it. So different levels of responsibility at each layer, basically. That's the idea of it. So that's what is the cloud. I don't know if anyone had any questions at this point. Yeah.
A couple of years ago, I read that the European Union was developing a big cloud thing to rival the big players.
Yeah.
I've not read anything about it since. Is
No.
it still happening?
I've got.
Why are they doing it? Is it just sort of to control the data?
Exactly that. So, you know, we talked about that sovereignty aspect earlier. It's the idea of basically having full control of the whole platform. So although AWS and Azure and that lot, you know, they will give you guarantees that your data is going to stay where you say it is, you don't know. You know, it's owned by an American company. You know, things can change in politics in America. Who knows? So if you want to make sure that you've got absolute control, the only way to do that is to use a provider that's run by a company based in your location. So for the European Union, that would be their do. I've heard about that for years, and it's never come up. And I don't know. I mean, there was a brilliant UK provider called UK Cloud, which went into administration recently, because the problem is it's very expensive, and you can't compete with these big hyperscale providers. So it needs serious investment to do. So I suspect that's why, yeah, it's not happened so far.
There is the alternative to that, which is some people have to avoid things like Alibaba as a Chinese owned.
Yeah, exactly. Yeah. Because you can't be sure exactly what the government is of that country is gonna say has to happen for that company. So we'll move on to migration. So why would you migrate to the cloud? Well, we've touched on this a bit already. Scalability, instant access to computing resources, okay? In the old days, when I first started in IT, when someone wanted a new application, we went to procurement, we had to buy a new server. That took about 2 weeks to go with all your approval channels. The server would then take 2 weeks to arrive from the supplier. I know, very quick, yeah. It was a small company, so and then someone, you know, one of the infrastructure team would then have to rack that server. They would install Windows or Linux, or well, probably not Linux back in those days, but an operating system on it, and then someone would install the application on it, and then maybe in 2 months' time, you'd have your application running ready for someone to work. In cloud, you can do all of that in less than an hour or two, depending on who you are and what you're doing. So that's a hugely massive benefit to companies in terms of agility and responding to demands and what you need. And what comes with that is what we call fail fast culture, where you can spin something up. Someone has an idea and they go, well, let's just try it. Let's spin it up and give it a go. And if it doesn't work, they can shut it down and delete it. And it hasn't cost much money. And if they keep doing that, you know, eventually they might strike gold on an idea, and it can be worth, you know, all of the effort that they've done on the ones that have failed, it pays off. So there's a lot more room for innovation, basically. And yeah, basically, if you do develop something that works, you're in a scalable platform. So you can scale it up really quickly to meet the demand that comes that way. It might need re-architecting, it might need a bit of, you know, tweaking here and there, but basically you're not in a position of, oh, I've only got a single server and now 2 million people want to access it, and oh dear, it's fallen over. So yeah, that's the huge advantage. And we've got an image of that basically in GCP. We've got a web server, we've got a load balancer. Basically, when the demand increases, the load balancer will automatically, or rather the auto-scaling group will automatically spin up more web servers to meet that demand so that customers can still get to that website. Another benefit, high availability and disaster recovery. So if you're a small company, can you run lots of servers all over the world without, you know, data centers all over the place? It's hugely expensive. With cloud, you can do that. So we've got Azure here as an example. They've got a region in the UK. They've got 2 regions in the UK, one in the south, one in the west. So you've got immediately, you've got a huge more availability at very little cost, because you're still only running this infrastructure. It's only costing you that amount, but it's spread across the entire UK. And of course, you could do that in America. You could spread it across to a completely different continent. So you've got massive amounts more of high availability. And disaster recovery, much easier to test. Again, in the old days, disaster recovery, you spent a day in a data center restoring backup tapes and it was a nightmare. And generally it failed and you didn't learn anything. Whereas now you can keep doing these things. You can test your disaster recovery plans. You can even switch across to your disaster recovery service, make that your live service and make sure that it works. So you know that things are going to work if there's ever a problem. So these are the huge benefits that the cloud brings you, and why it's why it's a great idea to move into the cloud. And the last one I've got cost efficiencies, which is always a bit controversial because basically, if done right, is the key aspect on this. When I first started working in cloud, it was a huge rush of companies that wanted to, and especially government companies that wanted to just, well, cloud, we want to move everything to the cloud. And they pick up all their virtual servers that they had all over the place, put them in the cloud, and they go, great, we're cloud. And that was it. They wouldn't do anything more. So those virtual servers would sit there running, doing what they're supposed to, but they're charging them every month for all of these servers that they're using. And in their data centers, they've got all of these empty servers doing nothing that they've paid massive amounts of money for. And they're going, well, why is this suddenly costing us so much money? And it's because they didn't do it right. They didn't think about what they were doing. So yeah, you don't just push things to the cloud and think it's going to be better. You've got to think about it. You've got to think about the way you're going to do it. There are potentially zero cost solutions. If you're a small company, free tier aspects of a lot of these companies, providers, means that you can do things for free. And if you haven't got many customers, you haven't got that much demand, you can actually run your whole infrastructure without costing you a penny until you start getting bigger. And then people, start using your services, and then they'll start charging you.
Cloud Guru, the training guys that ran their website for years.
Yeah, I think so. Yeah.
It was them.
Yeah.
18 months.
Yeah.
Their entire training library, so they're training people all around the world how to use cloud, and it's costing them nothing.
Yeah, I mean, so for those on YouTube, yeah, Cloud Guru basically ran all of their infrastructure about 18 months for cost them nothing. And it's only when they got bigger and therefore were making more money that they started having to pay. So it's a really good thing.
Great case study website called Have I Been Pwned? Have I Been Owned? Which is where you can go and see if any of your passwords have been leaked. But they run their entire thing on a mixture of, I think, Cloudflare, Azure, and AWS, like maximizing the free tiers.
Right. Yeah. Yeah. So that's another good point. Yeah, you can use different providers and use all of the free tiers to get your to get the most cost benefit out of it. Reduce staff costs. Obviously, that's controversial in terms of what it's doing. But the way I like to think of it is you're freeing your staff up to do more interesting things. So in traditional IT support, we used to spend lots of time doing the same thing again and again and again. If we get automation in to repeat those things, our IT support staff can actually start being profit driven. They can look for cost savings. They can do things that benefit the company rather than being a cost to the company. So yeah, that's great. But so as I said, lift and shift migrations, they're seductive because they're really quick. And you can go, oh yeah, we're in the cloud and it's all lovely and brilliant, but they might not be the best. And actually, what you want to do is transform as you migrate, which leads us into adopting a cloud native mindset. Everyone good so far?
Do we want to open another window in here? Is everyone feeling warm? Or are we okay? Okay.
All good.
Just to let you know, you can open windows.
Hold that.
Exactly. It's quite warm in here as well, yeah.
And then all of a sudden we pass out. Because you're too polite.
It's a fair point. Cool, right. So cloud native development is where we combine cloud computing and what's called agile methodologies, which is a way of basically developing, a way of project managing. I'm not an agile leader, so I can't use all the right terminology, but basically, yeah, the idea is to create software that's highly available, scalable and flexible, and rapidly adaptable, which is great buzzwords, aren't they? So how do we do that? Well, there's 5 pillars to this. There's something called microservices and serverless technologies. We're going to go into these in more detail. There's a process called continuous integration and continuous delivery. There's DevOps, which is one of the things that I specialize in, along with automation. And then there's the idea of observability and KPIs, key performance indicators. So let's work through those. Microservices. So this is an old traditional application, monolithic. It's a big application. All the code is written in one thing. It's got a big database that everything talks to. It's all one big package. Now, the problem with that is if you want to do changes to this part of it, you could affect this part of it. And if you've got to take the thing down, you're going to take down all of it and not just a bit of it. So if we move to a microservice architecture, we're looking to split all of those components up into different things. So this is an example of like a shopping website. So you've got front-end GUI, so the website basically. You've got the catalog service, so all the products that they sell are stored in the catalog. The shopping cart, obviously, the payment integrations, so how they pay via Apple Pay or credit card, and the order fulfillment. So, you know, if they're shipping a product, how does their order go from the cart to the right people so that that order gets to them in wherever they are in the world? So if we split all of those into different components and each one has its own database, if we need to do an update on the catalog service, we're not affecting the order fulfillment. We're not affecting the payment integrations. It's all contained within its own. And ideally with microservices, all of these things are basically doing a single or 2 or 3 tasks at most. So that if you, when you develop something, when you improve something, when you add new features, you're really improving your reliability because you're not affecting the rest of the application. And you do that, if you can, through something called serverless technologies, which are basically cloud native technologies. And serverless, the idea of serverless is basically everything's running on a server in the background. Obviously, you can't get away from that, but you don't really know that. You don't have any visibility of that. So, for example, we've got, I mean, this is an example of an application in AWS that I've drawn up. The purpose of this application could be anything, but what it's doing is we've got a website sitting in what's called an S3 bucket, which is just a storage bucket. It's just a load of files sitting there, okay? But we've got static HTML files in there. They might be running front-end JavaScript or something, but we've got no back-end server processing going on. There's no server involved. We've got CloudFront, which is a content delivery network, which distributes these website files all across the world so that someone in China or Japan, they get the same response times as someone in the UK or America. We've got Certificate Manager, which is doing HTTPS certificates so that we've got a secure padlock on our little web browser. DNS, which does the translation so that when you go to www.mywebsite.com, it goes to your servers here, your services. And then we've got the back end, and we've got something called DynamoDB, which is basically a database. And we're pulling data into that database from somewhere else. And these are Lambda functions. Basically, they're code. It's just a set of code that's pulling data from another area, be that someone's API or another website or another database, and it's putting it into our database. And that then feeds here. So we can have dynamic data in our database. So let's say a weather app, for example. This could be pulling the latest weather statistics from, you know, what they call the Met Office into our database, and then when this person looks and they refresh their page, they're getting the very latest temperature data. But we're not running any servers to do all of that. All of this, basically, if no one's looking at our site, the only thing that's costing us any money is a little bit of storage over here. All of this is free until someone starts using it. So it's really cheap and a really clever application way of doing the application. And if you need to do any updates or stuff, you know, if I need to update this, I'm not affecting this site at all. The website's going to keep running. No one's going to notice. So you can do really highly available, and all of these functions scale as well, I should say. So Lambda functions, for example, if they suddenly get loads of requests, it'll just spin up lots of Lambda functions all doing that single task, and they'll all feed that data into that person. So it doesn't matter how many people are going there, it will scale up to a degree with the demand, but it's not costing us much money at all. So these are the benefits that we can get from working in this way. Right, how are we doing so far? This is probably the most technical of all of it, I think. Continuous integration, continuous development. So the idea of this really is just, rather than in the old days where you had an application and then every quarter, every 6 months or so, you get a big update being downloaded and installed, and it would reboot the machine or all of those sorts of things. So break everything, exactly, yeah. Yeah. We're not doing that anymore. What we're doing is frequent small code changes. So the developers are looking at a bit of code and they're going, okay, what can we do better? What isn't working as we want it to work? Make those changes and commit them to a repository, which is just a area where you store code, basically. That will then trigger a build process. So it builds the software, and then it goes through a set of tests so that make sure that everything's working as it should. And then all these things could be manual. They could be automated. Ideally, they'll be automated because it'll be a lot quicker and a lot better. But it doesn't matter at this stage. It's just the idea of it, basically. Until eventually, basically, it goes through a review. People are doing quality assurance on that, make sure it's all working as it should. And then it gets sent out into production. And that's where we've got continuous delivery. So the idea of continuous delivery is, as people are making these updates, we deliver them. We don't do lots of little updates and sort of hold them back and hold them back and hold them back till we've got loads of updates and then deliver them. We deliver them as soon as they're there. And it's more reliable because you're only changing little bits of the code at a time. So there's much less chance of something going wrong. There's much more chance of someone noticing if something's wrong. And the product's just getting updated in the background. And because we're using that microservice architecture, the application still runs because we're only updating little bits at a time. And DevOps basically is how we kind of achieve this, because traditionally in a big company, for sure, you would have different teams doing all of these different bits. So you'd have developers developing the code, you'd have testers doing the tests, you'd have QA team doing the QA and all of that, and then operations people kind of doing the deployment onto the infrastructure, deploying the infrastructure. With DevOps, we're kind of either combining it so that the same people are doing those roles, or synergizing it so the two teams talk to each other, they work together. And I've done this with agile project teams, which is something called a product team. So that there's a product team that owns a bit of software, and all of the people who work in that software are in that team. So it's the same. You've got the developers, you've got the architects, you've got the support people, all of them work in that team, the product owner, and they all get together every day and check how things are going. And they're all responsible for making sure that product works. So it's not just developers developing something and then going, here you go, support guys, and the support guys going, none of this works. And sorry, I'm doing something else now. It leads to a lot more reliability, basically, and it's much more efficient. And this is what the big guys do, Facebook, Google, which is why you get so many updates to your applications all the time, because they're just constantly feeding these updates and deploying them. Then this is automation. I'm not going to go into too much detail on this because it gets a bit technical, but basically that what we saw before, we're just automating it. So we've got the developer at the moment that they commit the changes. It goes through a series of tasks through the repository that basically deploy those changes into, first of all, you've got approval stage just to make sure they haven't made a silly mistake. But it goes through an automated deployment process. This is something called Microsoft Azure DevOps, by the way, for those who haven't used it. And this a pipeline, basically, as they call it, will just automatically pull each task. And then you can stop it at various stages just to check, are things doing a bit of human intervention, basically? Is it looking like it should? So approval stages, they could be automated. It depends how much you trust who's doing this bit, basically. But eventually it gets into production, basically, and it just works its way through, and all the tests are automated. So you just the person will just get a look of, has it passed all the tests? Yes, okay, it can go to the next stage and things like that. And then feedback. Yeah, you get feedback, basically. So these approval people will go, the QA guys might go, well, it all works, but, it's telling them that our company's rubbish. We don't want that. So you can feed that back into this board, and then the developers get it. So it's just a circular system that just constantly evolves, which is why it's got that continuous integration, continuous delivery. Right. A final aspect of this is observability. And basically, this is an idea of monitoring your application, but using key performance indicators. And what they are is this application doing what we wanted it to do? Not just is the application working, is it actually doing what we wanted it to do? And that could be any number of things. It could be, is our website responding in less than 50 milliseconds? Or it could be, is this marketing campaign that we've sent out, is it effective? Are we getting, returns? Are we getting clicks? Are we getting people, responding to that marketing campaign? Various different things that could be used to measure this. But the key is it is measurable. It has to be measurable. So customer satisfaction surveys, are we doing the right things? All of these things, basically. And you still need operational monitoring. Is the application working? But you need also this aspect of, is the application doing what we want it to do? Because otherwise, what's the point? And that feedback then feeds back into that task board that we saw earlier. So the developer can go, oh, hang on, we've got a bug here, or, oh, this feature isn't really doing what we thought it would do, and the customers are telling us this. Let's change it to do what they're responding to us. And just constant improvement. That's cloud native development. Who's still with me?
Can I just say that you don't have to do cloud, whatever you call it?
No, of course not. You don't have to.
That's
No.
just the
no.
way people do stuff.
Yeah.
People use cloud with old-fashioned.
Oh, yeah, absolutely. I mean, the reason for doing it that way, if you can, it doesn't make sense for everything, obviously, but if it does make sense, it will be a lot more efficient. Your applications and your software will be more reliable as a result of it. So, yeah, but no, you don't have to.
You don't
But
have to do it.
no.
I don't.
That's your choice. That's your choice. Yeah. I mean, obviously, there's a big investment that goes into setting all of that up. If you've got no knowledge of any of that, you've got people that you've got to train. You've got all sorts of things. So, yeah, it's the idea is you're using technologies that you can only really do in the cloud.
Well, yes and no, because you can do
Some of it, but not all
you
of
can
it.
do the I've had arguments with people in finance and then have something built in just to prove a point.
Yeah.
Um,
Well, no, sorry. Yeah, continuous integration, continuous deployment. You're right. That I mean, but it's more of
it's
this.
a lot easier in the world.
Yeah.
To scale new
Yeah.
things up and go, let's just put 5% of our traffic over there.
Yeah.
Rather than we have to do everything. Oh shit, it broke.
Yeah.
A couple of problems I find with it. Number one, with my support, if you're spinning up and down web servers, and then you go, oh, no, we've got no help desk calls that customers are getting 404s. You know, oh dear, oh, let's go and hunt around for some logs.
The logs
Some
aren't
servers have gone. Oh, I don't know what they've got.
Yeah. I mean, that's it.
No, that's
About
the
the
point.
observability.
Yeah,
It's
that's
about-
an architectural thing. Yeah,
the
absolutely.
product I actually work with is all to do with key infrastructure, things like train stations and airports and stuff. So the change control process. So yeah, the change control CI/CD is great, and I totally agree with it, and I love it, in the up to the dev QA testy end, but then to get through all the hoops of an actual change control to a national infrastructure site and go, oh, yeah, we just want to push this little change, and then they go, and I suppose this is microservices, because you can go, well, I'm sure this only affected your CCTV system, but they're still like, yeah, but you made a change. We want to test everything from the ticket barriers to the, and you're like, but we only changed that system, but they have no confidence in that segregation of microservices. So I guess it's a culture problem.
Yeah, well, I was going to say that. Sorry to. It is basically that's a culture problem, and it's.
When Microsoft updated my laptop, it all broke.
And that's what I mean about in terms of training people and stuff like that, because you need people high up in the company to be on board with that kind of methodology, so that when people go, well, we don't want to do this, it's just like, well, you just got to trust the process. And
We've got
right, okay. So yeah, but we'll come on in a bit in security about chaos engineering and stuff like that, which is another great way of kind of getting your teams to trust what's going on. So data in the cloud, I was really hoping Lacey was going to be here for this because she's the data expert, but she's not, so I'm going to have to handle it. But data in the cloud, where are we? So storage and databases, that's all I'm going to concentrate on today. There's a lot more to data, but this is a beginner's kind of introduction. All of these things you could probably have a day's worth of talks on with various people. So, just a quick overview. But the two types of main storage in cloud, we've got object and block storage. We'll go through that in a minute. And then we've got databases, we've got managed databases, data warehouse, data lake, and analytics and processing. So block storage, I'm not going to spend too much time on this. Block storage is traditional storage. Your hard disk on your laptop is block storage, basically. So it's traditional in the sense that your data's chunked up into blocks. It's suitable for structured data, as they call it, like relational databases, or databases in general, to be fair. Virtual hard disks. AWS have elastic block storage, EBS. Azure use virtual hard disk, VHD. Disks that are connected to servers, essentially. And we'll come on to the advantages and disadvantages of both. Object storage is different. It uses metadata, which stores contextual information about the data, and it has a unique identifier so that it can be located. It's best for unstructured data. So this is just any old file, video, image, anything it basically doesn't have a structure to it. And then I've put used for a host of purposes. That meant to be examples. So S3, Google Cloud Storage, Azure Blob Storage, they're all object-based storage. So object-based storage is flat. There's no kind of file folder level hierarchy to it. You can mimic it, but on the underlying level, basically, it's just a flat layer. So block storage is fast if it's stored locally. And what I mean by locally is kind of in the same data center, basically. Incremental changes are possible. So you've got a 100 meg file, you make a little change to it, just that little change gets written to the block storage. That's what makes it fast. But the problem with it is durability is difficult at scale. So when you start getting to really big amounts of data, it's difficult to keep that data, the integrity of it, basically, without it sort of becoming corrupt, potentially.
It's funny you say fast performance if it's local.
Yeah.
Because you do end up being hamstrung by, of all things, the speed of light.
Yep, that is an unfortunate limitation. Yeah. Object storage, on the other hand, is lower performance, and the reason it's lower performance is because with that 100 meg object, if we want to make a little change to it, it's got to rewrite the entire 100 meg, so it makes it much slower. But it's very high durability. I think S3 has got 11 nines, is it, of durability, which is longer. Yeah. The S3 standard storage is 11 nines, which basically means, I think,
11 nines of durability and 4 nines of availability.
Yeah.
Which is just
Yeah. The 11 nines is like longer than the universe has existed or something.
I think what they say is if you stored a terabyte of data for 100 years, you lose 1 byte.
Yeah. Yeah. So it's really safe, basically. Your data's safe.
What do you mean when you say like it's 11 nines or it's 4 nines?
So that availability is basically, it's a way of,
99
yeah, it's a way of measuring
65 days.
how,
Like a probability of change.
exactly. Yeah.
Nothing's 100%.
No.
Forget that.
Yeah. So it's easier to scale to big volumes. So that makes it perfect for backups, archives, data lakes, things where performance isn't that important, but you've got large amounts of data. Managed databases. So this is what we talked about earlier a little bit, platform as a service. So it's a database that's managed by your cloud provider. All you do is say, I want a database, please. And then you connect to it and you start putting data in it. You haven't got to build a server. You haven't got to put an operating system in. You haven't got to patch it. You haven't got to put antivirus on. All of those things are taken away. Literally, you've just got a database that you can access. So yeah, all of those things are taken care of. Things like replication and backups as well. It's basically a tick box to say, back up this database, please, and it does it in the background. AWS I've gone with here again. We've got MySQL, MariaDB, Postgres, Aurora, which is Amazon's version of MySQL, Microsoft. Oh yes, that's right. Yeah, so Postgres, Microsoft SQL Server, and Oracle. All of those things are available in Amazon, and same with Azure and the others, I'm pretty sure. So with our, what we were looking at earlier, we're really just looking at, I've kind of put halfway through because we've still got a little bit of the fact that we're managing the database itself. So we're managing the application a little bit, but half of the pizza toppings, let's say, and then we're just cooking and eating the pizza. That's it. So yeah, the advantages, we've gone through that. Deployment's easy. Minimal management, it's scalable and available because we can configure backups and replication. Security can be improved if you do it in the right way. Again, these are topics we'll come on to in a bit. But the disadvantages can be cost because obviously the cloud provider is doing all this for you, but they're going to charge you for it naturally. So if you've got skills in that area, it might be cheaper to do it a different way, but it might not. It's something you've got to look at on each time. And control, you've got little to no control over some aspects of it, such as if you've got a new database extension type, for example, in MySQL or something like that, you might not have access to that straight away. It might take AWS a little while to provide that. So if you need that, you might have to deploy your own and manage it yourself. Data warehouse, here we go. This is where I'm getting out of my depth, but we'll go for it. So data warehouse. Fast access to the complex analysis of structured data from multiple sources. That's great, isn't it? What does that mean? Okay, so Data warehouse has been around for a long time, decades, I think. But the idea is we're taking data from lots of different sources. So a big company might have a customer relationship management system. They might have a enterprise resource planning system, like basically human resources, finance, all that sort of systems. SAP is a very good example of that, yeah. Other databases, files, all of that goes into this, what's called extract, transform, load. What that means is we're extracting specific data that we want from these systems. We're transforming it into a format which is useful to us, and then we're loading it into our data warehouse. So there's a processing aspect to this to make the data useful. It's structured data, which means that it's got a schema. It's all done by people that have lots of skills in data warehousing. I've got no idea. And or devs that don't know what they're doing. But yeah, basically we've got analysis routines that generally take quite a long time. I mean, it depends on the system you're using. In my day, they used to run overnight. And then useful data is basically available to consumers. So that might be someone in marketing. It might be someone in finance. They've got no technical background, but they're getting all of the data that they want in a format that makes it useful to them. That's the idea of a data warehouse, basically. And it will run generally very regularly, and it's all structured. And, you know, if you need a change, it's quite complex. Someone's got to write that change. And if you need more data from here, that's got to be changed to make sure it can accept that data. So it's all kind of, yeah, tricky to do, but very useful data on the outside, on the other side. Data lake, on the other hand, is data just coming in. So we've got no transform period here. We're just taking data into the lake in its raw format, be that media files, be that images, be that, I don't know, whatever, Word documents, PDFs, whatever format you've got. It all just gets shoved into the data lake. And then we've got data scientists who make use of it. So they will do analysis, they will run very clever algorithms and things like that on the data to see what can they do with that data, what's interesting. I worked for EDF for a while. They had loads of these sorts of things going on to look at customer data that was coming in and see what they could do with that data to make it useful for the customer. So ways that they could cut emissions, ways that they could cut customers' bills, all that sorts of stuff. So there's tools that you can get, which Lacey knows all about, like BigQuery, Dataproc, and these are just things that basically do that kind of thing. And then there's something called Google Data Studio, and all of the cloud providers have got their own versions of these, which makes it accessible to consumers. So they can make it into a nice format, basically a pie graph or whatever, so that someone that's looking at it can go, oh yeah, that's great, yeah, let's do that. And then that might go into the data warehouse if it's useful. You know, there's a link between the two, but the idea is basically you're shoving everything in and then you're making use of the data. You don't really know what you're going to do with that data at the point when you put it in the lake.
I think the important thing there is because you're not transforming it, you're not making any preconceived analysis of the data to put it into a common schema.
Yeah, exactly. Yeah, there's no preconceived idea of what that data is.
It becomes the power of it being a lake.
Yeah. Exactly. That's it. So that's data. Phew. I made it, yeah. How are we doing for time? I've got no idea. Oh, we're going to have to go through security really quickly. That's always the way, isn't it? Security people hate that. Don't worry about security. It's fine. Just enjoy yourselves. Yeah, my company's only called Secure Bubble, so yeah. Anyway, I haven't actually. I've only been trading a little while though. So. Right, risks with cloud security. Inexperience, pretty obvious. People not doing things they should because they don't know any better. Compromise of credentials, generally that can be linked with the inexperienced side. There's a good example of this just literally happened, I think, last week with Circle CI, where a phishing attack meant that some high-level credentials got leaked and, yeah, basically loads of data that got stolen and unencrypted. Insufficient encryption. So that's a big thing because people just generally say, is the data encrypted? And someone goes, yes. And they go, great. It's not enough these days. You've got to have more robust encryption mechanisms. Limited visibility basically means people doing stuff that you don't know about. So cloud is available to anyone. So anyone can open a cloud account and start doing stuff. So unless you've got processes and procedures, yeah, if you don't know about it, you can't make it secure. And insider threats, obviously, that's one that is never going to go away, unfortunately. Strategy. Okay, I'm going to rush through this because it's just a load of text. Strategy. It's really important, basically, but it's difficult when you're a startup to come up with a strategy when you don't know anything. So the only thing I would say is if you don't know what you're doing with strategy, get someone to help you with it. It's worth the money. Me? No, surely not. But if it's a bigger company, make sure the strategy's got approval from the top. You know, if the top isn't buying into it and making it happen, it's worthless. You need strategies for your identity, data, and infrastructure. So data for classification. How are you classifying if your data is protected or open to everyone or whatever it is? Least privilege, which just means giving people what they need. Don't give everyone administrator access, even though it's easy. Security, layered defenses, security in depth. You know, don't just put a firewall there and go, great, that's done. We don't need to worry about anything else. You need security throughout the entire layer of everything. Shift left means basically think about security right from the beginning, right from the start. Get your developers thinking about security. Put security tools into their hands like Sneak or Chekhov or things. There's tools out there that can help make sure code is being written in a secure manner. Detection and response. When something goes wrong, how are you going to deal with it? It's no good thinking about it when it goes wrong. You need to have plans in advance of what you're going to do if your credentials get stolen or your data gets stolen or something like that. And then chaos engineering, which I mentioned earlier. This is basically trying to intentionally break your live site, which sounds crazy, but it's more and more something that people do, because the more you break it, the more you know how to fix it, the more you can automate that fixing, so that if something breaks, it gets fixed and you don't have to worry about it. So it's a really good, with the microservices architecture, you know, you can come up with strategies that basically mean things get fixed as they get broken. And you can, with chaos engineering, you can do that. And there are companies, specialist companies, that will help you achieve that. Inexperience, this is basically someone's credentials being stolen because they've put it into a public S3 bucket, or they've put it into a public code repository, a GitHub repository. Yep, Twitch have done it. Loads of people have done it. And it's because it's sitting there, no one might know that it's there, because they just check it in. There are tools that you can get that will help you monitor for these things, basically identify it and alert you to it. So look for those sort of things.
Bad actors, as they're called, finding that sort of thing in a public GitHub repo is under 3 minutes.
Yeah. There are people basically scanning these things, looking for credentials constantly. So if someone does it, you can get compromised really quickly. The other example we've got is someone building a web app with a web application and a database, but they don't really know what they're doing, and they've put it all on the public subnet. They've given the database a public IP, and they've forgotten to put security groups, so there's no firewall, which means that anyone can access that database. So any data that gets stored in that database could potentially be leaked out. And that's just because these cloud makes it really easy to get things up and running, but it can be too easy to get things up and running which aren't secure. So yeah, you need to have a little bit of training or a little bit of watch some YouTube videos and do it the right way. Or you can contact me, of course. Encryption, right. I won't go into detail on this because I don't know how it works, but encryption basically is two different types of encryption: symmetric and asymmetric. Symmetric uses a single key to encrypt and decrypt. Asymmetric uses one key to encrypt and one key to decrypt. We come on, I think, to why one is better than the other, do we? No, we don't. Okay. So this is quicker because the key doesn't have to be that complex to do this. So it doesn't use as much computational power. But the disadvantage is, obviously, if you encrypt something and I send it to someone else, I send it to you, how do you then decrypt it unless I give you the same key? So I've got to get you the key as well somehow securely without anyone else getting that key. It all becomes a bit tricky. So that's where asymmetric encryption comes in, because you could give someone your public key Anyone can have it. And then they can encrypt that data. And then when they send it to you, you can decrypt it, but no one else can decrypt it. So it doesn't matter who has your public key. They can, the whole world can have it, but they can't do anything without the private key, which is the one that you hold securely in your, not your Google Drive, somewhere more secure than that. Or not last pass, yeah, indeed. So that's that. And the reason I bring it up is this is kind of how the two work in tandem, basically. So if we look at a website, when you go to a website, you go to HTTPS, it gives you what it's called its public service certificate, which is its public key. It's got two benefits. Number one, you know that the server is who it says it is. So www.microsoft.com presents that certificate. Your browser goes, oh yeah, that is www.microsoft.com, I trust it. Then the browser will create a symmetric key and encrypt it with the public key. It sends the symmetric key to the server. They've both then got the same symmetric key and everything else happens through that. It just speeds things up, basically. May be interesting to some, may not be interesting, but there you go. That's how it works. So best practices for encryption, we've got to encrypt data as it's traveling across the internet, obviously, but also when it's sitting now. It's not good enough to just encrypt data as it's traveling. So many hacks now, you see it in the news and they say it was a load of unencrypted data and they got hold of it. If it had been encrypted, they might have got hold of the data, but they couldn't read it, so it wouldn't have been any good to them. Yeah, there's a load of stuff here. Just use good encryption, basically, is all I'm going to say. There's lots of modules that are old. They're no good anymore. They can be cracked in minutes. So you need to use modern encryption stuff. Any keys that you have must be securely stored. Don't email them to people or anything like that, for God's sake, because it's a bad thing. And something called key rotation is a real must, which is something that the cloud providers will help you do with their own key management systems. And it means that however often you get it to set, it will change the encryption key that's being used without your application having to know about it. It's doing it in the background. And that way, if that key gets compromised, the only data that they can read is these two documents. They can't read anything else, basically. So it's limiting the damage that it can do. Limited visibility. Oh, this is one of these slides where we've got a bit of animation. So this is a company that's got a web application and they've got all the good practices in. They've got high availability. They've got a WAF, which is a web application firewall, makes things more secure. All lovely stuff that makes it nice and secure. Someone comes along and goes, I love your application, but I need to do this and it won't do it. And the company goes, tough, you have to conform to ARN standards, blah, 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 you can't do it. And the product goes, well, I've stuffed that, I'm just going to build my own application. So he creates his own AWS account and he creates his own application. But he's just put it all in a public subnet, like the problem we saw before, could be exposed to the internet. People could be getting access to that database. We haven't got the web application firewall doing what it's doing. We haven't got these other security aspects running. But these people don't know anything about it because it's running in a completely separate account. There's nothing you can do to stop that happening apart from when people want something and they've got a good business need for something, you need that agility, which is where cloud native development comes in, so that you can actually do these things. You can respond to these new features quickly for the business and the business needs and respond to those demands so that you don't get that problem. How do we fix it? Logging. Got to enable logging. If we're not logging, then we can't tell what's going on.
Worth saying as well that those logs don't live on servers, they live in things that have no visibility off the servers.
Yeah, indeed. Yeah, so yeah, that's a good point. So if you've got servers, you're logging, it's no good just logging them to the servers. You need to pull those logs somewhere else, be that the cloud provider's account or services like Splunk or other things that you could pull logs into. And yeah, basically, you've got to have those logs available in order to tell if something's gone wrong. Auditing, don't use generic accounts. Everyone should have their own account. You can use that to track suspicious activity. Is that user doing something that they shouldn't be? As I say, it's not to encourage blame culture. It's not so we're going, oh, you did this. No, it's about using it to say, well, that user's doing this, but they've never done that before. Is that okay? Do I need to investigate that? And it might be it's fine, it might not. But if you've got that auditing, then you can tell. And protective monitoring, which is the idea of automating this sort of stuff, basically. Look, not just logging, but actually looking at the logs, seeing if there's anything wrong and doing something about it. And use automation. to quickly identify, notify, and remediate. Those are the cloud native tools. I've just put a load up there that you can use. There's loads more. That's not all of them, just a subset of them. So yeah, cloud providers have gone to huge amounts of effort to make these tools available to help you do things securely in the cloud. Use them. Or if you don't know how, get someone that does, or watch some YouTube videos, or learn. It's all good. You come here and ask questions. It's all good fun.